So let's look at a couple more problems for writing functions with exponential decay. And before we look at this specific problem, just remind yourself what the general formula looks like, where we have some function, usually of time, t, is equal to a multiplied by b raised to that t power, where a is our starting value, since if you plug in 0, you do get a back, since b to the 0 is 1. And b, that's just the base, or in these equations or these problems, that's going to be our decay rate. So we need to just figure out what a and b are. And let's now look at this specific problem. So we have a car that sells for $5,000 and loses 1/10 of its value each year. Write a function that gives the car's value, v of t years after it's sold. So with all word problems, you want to start by defining your variables. So v of t and t, we need to come up with, in our own words, what each of these represent. So v of t, that's the car's value, t years after it's sold. So this is the value of the car, and we know that its unit will be in dollars. And then t looks to be time, and we're talking about years. So our unit for time is years. And now let's go back to our information here. The car sells for $5,000 and then loses 1/10 of its value each year. So when time is equal to 0, the value of the car, or v of 0, is $5,000. So we know our starting value. We know what a is in this formula, but now we need to figure out the base. We need to figure out how much is decaying from one year to the next. So to do that, we need to be a little bit careful, since we're starting with the current amount, or the original amount of the car, and then subtracting 1/10 of that value. So let's rewrite this. We have that our base, our decay rate, is equal to the current value of the car, which you could write as 100% or just 1, and then we're subtracting 1/10 of that value each year. So in other words, we're subtracting 1/10 of the value of the car, of that 100%. Now this overcomplicates it a little bit. You could also just write the value of the car as 1 and then subtracting 1/10 from that. And you can see that these are equivalent, since 100% is just equal to 1. Now, subtracting fractions, we can rewrite 1 as 10 over 10, and then subtract the numerators, we get 9 over 10. So in other words, from year to year, the car's value is going to be multiplied by 9/10. And we could make a quick table here. Actually, let's do that at the end. Since we found our base and we found the starting value, we can just apply that into our formula now. So v of t is equal to 5,000 multiplied by that base. Let me just rewrite that. That base of 9/10, all raised to the t power. And this is what we think is our answer, but we want to double check our work. And to check this, you can make a quick table. So we're looking at different t values and what the value of the car is there. And for t is equal to 0, we know it's at 5,000. When we're looking at 1 year later, we're subtracting 1/10 of the value of that car. 1/10 of 5,000 is 500. So we're subtracting 500 from that, and that brings us to 4,500. But notice it's the same thing as multiplying 5,000 by 0.9. You can check that with your calculator. Now for year 2, 1/10 of 4,500 would be $450. And subtracting that brings us to $4,050. But again, going from 4,500, we're just multiplying by 0.9. And the next step, we'd subtract $405, since that's 1/10 of that value, and so on. But to check this, we just want to plug in one of these time values and make sure our formula works. And let's just plug in 2. So when we do that to our formula, we get 5,000 multiplied by, I'll write it as 0.9 squared. So that's 5,000 by multiplied by 0.81. And if you double check that with the calculator, you do get 4,050, which is what we got by just thinking it through. So we checked our formula and it did work, which means we can feel confident typing that 5,000 multiplied by 0.9, or 9/10 as a fraction, raised to the t power into our box here.